as well as some of their training on their product. We talked a little bit about the linking infrastructure earlier, but the linking infrastructure was really important. That was a separate purchase ahead of time to get that in place. The T1 ring is switched by a product called Data Pro. We probably would have, if we were to do this over again, we would have done it with the switching process that's in the Harris Mux that they have available. I think either way is fine. Actually, the Data Pro does give us some contact closure outputs and things like that. To be honest with you, we were familiar with the Data Pro. We were comfortable with working with the Data Pro, so we stayed with that on this project rather than going with the Harris, but it worked out real well. The exhaust system, again, it's a 4.9 all outdoor unit that we did, so it was Cat 5 down power. And again, that worked out well for tower loading purposes and things like that. And that system's been up and running. Only downtime on it has been for scheduled maintenance, and there hasn't been really any downtime because it's a self-healing network by the time we really have it. We do have some Carlson wireless hops for some spurs off of that microwave ring for some last mount things for other phone lines for some receive sites and things like that. The Tate Simulcast equipment really only requires a 4-wire circuit, which we're providing through those Harris Muxes. We do have another system being deployed by one of our customers that's self-maintained. They're actually doing the install and they're doing it over phone line, and they're not having any major trouble, but maybe we can do a case study on that one next year. But again, the microwave project has really proven beneficial in all of this. And I'd say that some of the savings that they've got that was really unbudgeted savings they weren't expecting until we brought the microwave solution to them is what's helped fund their simulcast and narrowband projects in the future. So, together really links up well. So this is a block diagram, a rough diagram of the Exalt diamond in there, and just showing one of the technical drawings actually that we provide back to the customer and that we use for our day-to-day operations. Didn't blow up real well into the PowerPoint, but again, just shows that for example, down here at our Wilmington tower, traffic can go either direction back. If the link goes down between Wilmington and Lockport, everything's going to reroute, and that has just been great reliability. So we actually increased the reliability for the phone company and saved them money, and then provided the right kind of circuit for simulcast in general. So overview on the system was the QS2. All the central site equipment and the voter is actually located at WESCOM. We do things a little bit different than what Tate wanted us to do initially. We don't have any of the receive sites running through the QS2 cards. That was a little bit of a learning curve between us and Tate because they engineer everything to go through their QS2 cards. We just looked at it as a separate transmit system and a separate receive system, and we let the voter do the work. The voters were the console interfaces, and that works out really well for us. And they were perfectly happy supporting it. When Terry Collins from Tate came out to do the commission, he said, absolutely no problem doing it this way. So again, once we all understood what we wanted to get accomplished there, it worked out quite well. It also allowed us to keep the old repeater. It was actually narrowband capable, so we narrowbanded it, and it's in there as a backup. So if there's a problem, which there hasn't been yet, probably happened today, well, I'm on my way home. But if there's a problem with the simulcast cell, so to speak, they could go back to that single site transmitter with ease with the JPS motor. And we also use CTI products for control of that motor. The transmit sites were all located. 2 of them are water towers and 2 of them are actually communication towers. So we're down 150 feet or 100 feet on some of those sites. And wide open terrain, we don't have any mountains or anything like that we were contending with, just wide open terrain. And the monitor receive site we actually put at the Wilmington fire station radio tower. The monitor receiver, if you're not familiar with the QS2 system, it does a training. So what happens is, we actually have it doing it once a day right now. We could probably back that down, but for basically measuring the delay of the path on the circuit, whatever it might be, it goes through about a 20-second to 30-second process for all 4 sites. Doesn't take long at all. But the monitor receiver actually listens and it transmits each site individually with a low level data. The user doesn't hear it, it goes out carrier squelch. And the monitor receiver measures the delay, how long it took to hear that, and then recalculates. It really keeps things on track as far as delay and stuff like that. And really, we put the system up and trained it once, and it learned out all the timing and worked well. One of the other concerns we had was in the microwave ring. If we switched a different direction, you could have almost 16 or more routes back with 4 sites. We were concerned about the difference there, but again, the data probe switching and the delay and exalt is so minimal that the data equipment doesn't even know the difference. In fact, when we force the data probes to switch, we don't even, it happens so quick, we don't get an alarm on the Harris Mux. It doesn't even know the T1 went away. So if we get a Harris Mux alarm, you start to worry a little bit because something else is a problem. But we put the monitor receiver down in Wilmington. It needs to be somewhere where it can hear everything. We could have put it pretty much anywhere and heard everything, but we kind of put it down in the middle there. It was on our, it had 2 paths back to the central site equipment, so that was one of the keys for where we located that. And we got just a couple pictures, basically of the. This is the brains of the Tate system, and then we got the JPS voter right down below it. I mean, that's it. It's very simple. When you get out to, there's no transmitter at this location. This is just where the central site equipment is at the dispatch center. We get out to one of the transmit sites. You've got your base station, your frequency reference, and your control card. And we like the fact that it was pretty much a turnkey package, one vendor, one supplier for the QS2 system. And we could go back to one place if we had a question or a problem, things like that. Real happy with the 8100 base station. We used to use a lot of MTR 2000s in the past and Quantars. Our techs like the design of the base station. It's modular. It's very configurable. They can work on it. So they're real happy with the performance of it. We especially like the Ethernet interface on it as well. All of our sites have Ethernet that rides on the side of those T1s with the exalt running, so we can actually remotely program and go through all kinds of diagnostics on the Tate base station. When we first put the system up and we're testing, we had an officer who was complaining of coverage in an area. From the shop, our guys could remotely log into that base station and measure the signal quality of its incoming signal strength, and have somebody else go to the same area with another portable or mobile, and that's huge. I mean, it just saves you a lot of time, windshield time, things like that. So what did we learn? Our lessons learned: not to be afraid of simulcast and VHF. In our area, everybody said, can't be done, don't do it, it doesn't work. And that was probably because one agency had an unsuccessful project many years ago. So we're not scared of it. There weren't any great innovations or inventions that we had to come up with, which was huge. It was well designed by our staff and by Tate's staff. And our overall experience from putting our first system in is that we're going to, we've learned from it. We can probably speed up our time to implementation. But we stage every system at our shop. We use it actually as a payment milestone for the customer. A lot of these fire chiefs don't know what's in the water tower. They can come in and look at it, see it, hey, okay, here's actually what we just cut a check for $200,000 for. They may forget that they saw it, might not even understand what they saw, but it works well. But for our technicians, that staging experience is invaluable. So be able to work on that entire thing and have it operate in the shop and before it's deployed is huge. And it gives us a chance to maybe train some of the other techs on it that aren't working on the project directly, but might be in a call-out situation, things like that. So our end result was that we got the customer what they wanted, we got them simulcasted, we got them narrow-banded. They are able to retain their additional 2 channels that went away as backup frequencies or repurpose them for other use, so that works out well. And our customer's really satisfied to the point that actually the 4 channels listed at the bottom there are being quoted right now to be installed. So we've been real happy. A couple of these quotes that are on here are from one of the police lieutenants in Shanahan, police department, but he lives in Wilmington. And even if you see in his words, he says, well, when I go to Wilmington, their repeater works real well too. He still thinks of it as two separate repeaters. Doesn't realize. He knows he doesn't have to change channels. When he gets home, he can hear what's going on in his town. So he's real excited. So, thank you very much.